Hi, grade 12. Let's work on this problem. This is vertical projectile motion. They say a learner standing at the bottom of the building throws ball A vertically upward at the speed of 11 meters per second. So what are we given? We are given the V initial here, which is 11 meters per second. So this is what we have so far. And then we know that it reaches what? Maximum height T. So V final at max is 0 meters per second. That's what we know so far. So they say that after 0.72 seconds, another learner standing on top of the roof of the building throws ball B upward. The ball reach point T. We know that point T is maximum, which will make this ball B to also have a V final of 0 meters per second. Okay, we are happy with that. So the ball will reach what? Point T at the same time. So let's try to answer this question. What is the difference between a free fall and a projectile motion? So remember, the free fall is a motion of an object. So the motion of an object is a free fall. And when we talk about the projectile motion, we say when the object is given an initial velocity, like this one, VA, we apply an initial velocity, then we say this is what? This is projectile. But please also consult your exam guideline on how to answer 4.1. I'm only interested in calculations. So 4.2, calculate the time taken by ball A to reach the maximum height at T. So this is for question 4.2.1. Let's first choose direction. I'm going to take up as positive. So when I have up as positive, I need to create my data. So now they say the time taken by ball A to reach maximum height. So we need delta T, question mark. And then the maximum height, what do we know so far about ball A? We know that the V initial is given as 1. We set up as positive, so this will be positive 11 meters per second. And my V final, which is 0 meters per second. Okay, so now what else do we know about this? Okay, we're just gonna use the formula that doesn't have delta y. So now we need to choose the formula to find the time taken by ball A to reach each maximum height. So the formula that we're going to use to answer this question is V final, it's equals to V initial plus A delta T. Look at that. We forgot to write A on our data, which is very important. Remember, A is the acceleration, which always acts downward. And we set up as positive. The acceleration always goes down. So it will be negative 9.8 meters per second squared. Okay, so with this information, we can find the time. So the final velocity we set is 0. This is equal to initial velocity, which is 11. So I'm just going to say this is 11 plus acceleration of negative 9.8. Then this is multiplied by delta T. Let's solve for this. The 11 comes this side to be negative, and this is equal to negative 9.8 delta T. Divide both sides by negative 9.8, negative 9.8. So when you punch that on the calculator, delta T, let me also do this on the calculator. 11 divided by 9.8 gives us 1.12 if we round it off to 2 decimal places. So this is 1.12 seconds. And that's the answer for 4.2.1. So now I'm going to answer. Let us work on 4.2.2. So the time that will take by ball A to reach point T, the time it will travel through this path, it has delta T to be 1.12 seconds. So let's answer the next question, which is 4.2.2. 4.2.2 says they want us to find the initial velocity of ball B. Right. So if we say the initial velocity of ball B, we are looking for V initial. So let's create the data. Right. So we are looking for the V initial question mark. Then we know that the final velocity is 0. Right? And then what about delta t? What about the time that it will take ball B to reach its maximum height? Look at this statement. After 0.72 seconds, another learner standing on the roof of the building throws ball B. So this tells us that they said these two balls, ball A and ball B, will reach this maximum height at the same time. So to find the time traveled by ball B, we can take this guy here and subtract the 0.72 seconds, because remember, they will reach the maximum height at the same time. So the time for ball B is going to be 1.12 seconds. We minus that 0.72 seconds. I hope this makes sense. Therefore, your delta t is equal to, let me quickly put this on the calculator. So this will be 1.12. We minus 0. We're going to minus 0.72. So this is 0.4 seconds. This is the time ball B will travel through this part. So through this part, our delta t is just 0.4 seconds. Okay, so I think now everything is good. Let's also consider acceleration. Remember, acceleration is going to be, this is moving up, and we said up as positive, the acceleration always goes down. So this will be negative 9.8 meters per second. Okay, so let's use the formula that doesn't have delta y, and the formula is V final. It's equals to V initial plus A delta t. So when we substitute, we know that this will reach maximum of 0. Initial velocity is what we are looking for, plus into negative 9.8 times delta t, which is 0.4. So guys, can you see that this has what we call a positive marking? It has a positive marking from the previous question. So if this delta t is wrong, you're going to lose the marks for this 4.2. So let us quickly work this thing out and see what we get. So now I know that V initial, it will be 9.8 times 0.4. So it will be negative, but we'll bring it to the other side to be positive. So this is 9.8 multiplied by 0.4. So which gives us 3.92. So this will be positive 3.92 meters per second. So this will be the velocity that ball B was thrown upward with. I hope you guys are happy with how we answered the 4.2.2. So the trick here was to find the time ball B will travel from the rooftop to the maximum height. So now for 6 marks, oh, this is 6 marks and we don't have a space to work on that. But let's try and work on the problem. They want us to find the height of the building. So to find this part here, the height of the building, we can find the height traveled by ball A. Then we can find the height traveled by ball B. Then find the difference between these points. So what I'm trying to say is that if we can find the height from the ground to T and subtract, so if we can find this path traveled by A and then subtract that height, this will give us H. I hope this makes sense. So let's work on it. First thing first, let's find the height. So this will be 4 0.2.3. Let's find the height of ball A, traveled by ball A. Okay, so now to find the height of the building, we first need to find the height that was traveled by ball A. So I'm not going to do that because we don't have much space. I'll just write down the formula. So we need the formula that has delta y. We can use VF squared. It's equals to V initial squared plus 2A delta y. So I'm going to explain when I do the substitution. Remember, ball A, it has the final velocity of 0. So this will be 0 squared, which is just 0. It's equal to V initial. It was given as 11 meters, if you still remember. So this will be 11 squared plus 2 into, remember the acceleration. The acceleration is going down, which will give us negative 9.8. We still have delta y. Okay, so now when we solve this, we isolate the 11 squared that will come on the other side, then divide both sides by negative 9.6. Right, so the 11 will come this other side to be negative. I need you to pause the lesson and isolate delta y. So on my side, I have that delta y for ball A, it's 6.17. So this is 6.17 meters. Because when you solve this thing, you're going to have the answer of 11 squared to be equals to negative 19.6 delta y. Then you divide both sides by negative 19.6, divide by negative 19.6. So then you'll have your 6.17 meters. So this is the distance traveled by ball A. Okay, I hope this makes sense. Now let's go and find the distance traveled by ball B. So for ball B, we're going to use the very same formula, VF squared, it's equals to V initial plus 2A delta y. So the V final of this one is also 0. The V initial is the one that we calculated. Where's our V initial? This one for ball B. Can you see that if you get it wrong, this will affect your answer? So this will be equals to 3.92 squared plus 2 into negative 9.8 delta y. So we just have to isolate the 3.92 squared to the other side and divide it by negative 19.6. Then this gives us delta y is equals to, let me also put this on the calculator. Please make sure that you pause the lesson, punch that on the calculator, and on my side I have my answer as 0.78. 0.784 meters. So if you still remember, we said that to find the height of the height, we need to take the height traveled by ball A, subtract the height traveled by ball B, and this will give us h. So now the height will be that 6.17 meter subtract 0.784, and this gives us, let's punch it on the calculator, guys. I'm very sorry about this space, but please make sure that you pause the lesson and work this thing out. So this is 6.17 minus 0.78, which gives us the final answer of 5.39 meters. And that's it for this lesson. This is how you collect the marks. So let's see how many marks we have so far. This is 3 plus 4, 7 plus 6. So 7 plus 6, that's 13. Because now on this one, please also make sure that you consult your exam guideline on how to differentiate between a free fall and a projectile motion. And that's it for this lesson. This is where we're going to stop on this problem.